Hey everybody, Monty's back. So Thursday in class we discussed rise, run, and how rise over run can be used to actually calculate distance. Okay, so why do we need distance? Well, if we want to find the area, okay, the area of a piece of carpet, it's length times width. Well, how do we get those distances? We use slope, right? We count how far up, how far over, and we multiply. Perimeter, how much distance around an object, right? Well, in order to do that, we have to know all the distances around, okay? Well, unfortunately, the real world is not that easy, and we have shapes that aren't that easy, okay? Well, in order to find these distances, we're going to use the slope, up 3 over 4. Okay? And by using slope, we can prove that it's a parallelogram. We can prove what type of a shape it is. And we can actually calculate distance. We can calculate the distance using slope. Okay? And then we had a discussion about why do we do this? Okay, well, we want to discuss the real world, right? We want to describe the real world mathematically and this idea of the distance of a street. And again, by using the slope, we can calculate the length of Pine Street. Yes, we can. Now we got to do some practice, okay? So in class we talked about this area. You can see the other video, and then we talked about how the difficult problems were. But we need to do some practice, okay? So distance formula. It turns out we're going to use the rise and the run to calculate distance between 2 points. This leg and this leg to find the distance between those 2 points, okay? A squared, B squared, C squared. It's called the distance formula. Okay, so A squared plus B squared is equal to C squared. And then on Tuesday, I made sure that you had a calculator so you could do this math. If you ever want to Google, the guy's name was Pythagoras, and it's called the Pythagorean theorem. Okay, so what buttons are we interested in? X squared and square root. And all we do is take any segment, any line segment, and we go down, over, and that's what allows us to do that calculation. Okay? So here we go. The distance between two lines is nothing more than the rise over the run. Okay? The rise and the run. The rise and the run. This leg and this leg. A squared plus B squared equals C squared. Rise squared plus the run squared is equal to the distance we're looking for squared, right? This AB, segment AB squared. The leg, this leg and this leg. One leg squared plus the other leg squared is equal to that distance AB squared. So let's do some math. Here we go. Okay. According to this rule, we want to take the first leg squared. Second leg squared. And it's equal to C squared. Well, 4 times 4 is 16. 10 times 10 is 100. And that is equal to the distance we want squared. Add them together and we get 116 is equal to C squared. Now we take the square root of both sides to undo the C squared. And C is going to equal, grab a calculator here, turn her on, clear it. Now, our square root button on this calculator is right here. Second x squared 116, enter. 10.77. Okay. Now the reason I wanted to spend a day on calculators is because, do you see I had to put the square root in first to get the answer? Well, let's look at the desktop version. Okay. When we hit the desktop version, we're going to type in let's clear it first. Type in 116 and then hit square root 10.77. See that? So this one, I put the number in first, then hit square root to get 7.77. Okay? All right, next one. This leg squared plus this leg squared equals that leg squared. So 5 squared plus 5 squared is equal to the distance that we're looking for, squared. 5 times 5 is 25. 5 times 5 is 25. And it is equal to c squared. Well, we know 25 and 25. Add them together and we get 50 equals c squared. Now, to get c by itself, we take the square root of both sides. And we get c equals, well, 7 times 7 is 49. I'm going to use this calculator again in case you don't have that fancy one. And we're going to go, what was it? 50, 5, 0, hit that little radical sign, 7.07. All right? All right, so hopefully that was helpful. Okay, there's one more for you to try. Okay, and we have a little bit of a challenge problem here, right? Oh, where'd it go? Where'd it go? Challenge problem's gone. Okay, so now our challenge problem for the day outside of class is to find the perimeter. Okay, we want to find perimeter. Well, perimeter is distance around. Well, we know this distance, just count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So that's 5 plus 7 plus something. Well, we know how to find the distance now. Let's use the slope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is 5 and 7. By using the distance formula, we can find WX. WX, that segment squared, is equal to the rise squared plus the run squared. 5 times 5 is 25. 7 times 7 is 49. And that's the segment we want squared, because if we could get that number, we win. So WX squared equals 74. Again, we got to undo the square root. Undo the square by doing the square root. Let's grab our desktop, clear it. 74 square root 8.6. 8.6 8.6. Final answer, 5 plus 7 plus 8.6. 11, 18, carry the 1, 9.8. Okay, hopefully that was helpful. We'll see you on Friday.